Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Time Lapse of the Star S301 Orbiting the Black Hole in the Center of the Galaxy. So, what do we see here? Well, here we're going to be watching an animation showing the orbit of a star known as S301 as it orbits around the black hole at the center of our galaxy. Now, as we look at the image here, we will see two objects that are labeled. One is the star known as S301. And also we see what is labeled Sagittarius A star. So S301 is the star we're talking about, and the Sagittarius A star represents the center of our galaxy, and in fact the black hole at the center of our galaxy. This is a very massive black hole, about 4 million times the mass of our own sun. Now, the animation will show the orbit, so let's go ahead and play that and repeat it so we can look at it as we discuss. And we'll see that as we do this, the star comes here. It starts out towards the upper right, and we'll see as it moves in, approaching the black hole there. Watch as it picks up speeds and then whips around and turns very quickly. So this is something that we can actually see on relatively short astronomical timescales. So we are measuring this in years here, and it takes about 8 or 9 years for this star to make one orbit around the supermassive black hole. But that means if you watch how it orbits, notice how slow it moves when it is far away from the black hole and how fast it moves when it gets close. And it whips around that black hole. See how it just turns around very quickly in the matter of days to weeks. It has gone from going one direction to turning nearly 180 degrees and heading right back the other direction. It takes a lot of mass to be able to take a star and flip it around like that. So we've got the star going one direction. All of a sudden, in a very short time, we've taken that star and now it's moving the other direction. We can use that. We can use the orbit of this star to calculate the mass of the black hole at the center. So with multiple orbits, we can get a pretty good estimate of how massive that black hole has to be. And we estimate it at about 4 million times the mass of our sun. Decently massive, but there are far more massive black holes that have been detected as well. Now, the star comes close to the black hole, but not too close. It actually comes about 10 astronomical units from the center of the galaxy, from that black hole. That's about the distance of Saturn in our solar system relative to the sun. Now, you might think that would cause the star to get swallowed up by the black hole, but that's not how this works. When the star comes close to the black hole, yes, we can see the different effects of the gravity of the black hole. But unless you get really close to it, which close to what we call the event horizon of the black hole, it would not be close enough to swallow up the star. Black holes don't just suck everything in. Objects can orbit a black hole just as they orbit any other object. It's only when you get too close to that black hole, and that's much closer than the distance of this star, that you really see those very extreme effects. However, this star is close enough that some of those predictions of general relativity, things that would happen when you do start to get close to the vicinity of a black hole, some of those measurements can be tested by studying the orbit of this star. So that was our picture of the day, titled Time Lapse of the Star S301 Orbiting the Black Hole in the Center of the Galaxy. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.